All right, so let's see what you can do as a data scientist. So obviously there's so many things that you can do as a data scientist, but let's look at a simple example as given here in this book. So let's suppose that you've been hired by a company to provide some advice on how to improve sales of a particular product that they sell. So they give you a data set, meaning some real entries, some historic information of the different media outlets that they spent money on and the resulting sales after spending that much money on them. So let's look at an example here in figure 2.1. Um, you can see that, for example, when they spent $50,000, and by the way, these numbers here are in thousands of dollars. When they spent $50,000, they had different results in the number of units that they sold. So sometimes when they spent $50,000, they got, for example, here, what, 6,000 units sold. And sometimes they had 9,000 units sold, and so on and so forth. Same thing here also when they spent $200,000. You can see it's a little bit more dispersed, right? So, for example, they sold at one instance 11,000 units or 10,000, whatever that might be. And here then you can see this is another instance. And another time when they spent $200,000 as well, they got maybe what? 17,000 units sold, and so on and so forth. And then they give you also the information for how much they spent on radio advertising and newspaper advertising as well. So they're asking you, can you build us a model that would help predict the sales on the basis of the three media budgets? Meaning that can you give us a model that would tell us that if we spend X amount of units or X amount of dollars on TV and Y amount of dollars on radio advertising and Z amount of dollars in newspaper advertising, all these three together, can you predict to us how many units we'll be able to sell? And that is exactly what you'll be doing for them. You'll build them a model that would take all this information, all the different instances that they had for TV advertising and radio advertising, newspaper advertising, and the number of units that were sold based on spending that much money, all the different instances. And then based on that, the machine learning model will be able to build an association between spending on TV, radio, and newspaper and the number of units that would sell if you do that, meaning that you spend X, Y, and Z amount, that's how many units that you'll be selling. And that's very valuable for companies because instead of them guessing, because they can just say, well, this year we're gonna have $200,000, for example, as a budget to spend on advertising. So look at the different information. You have so many different instances in each one. So how do they know how many dollars spent is gonna give them how many units sold in given all three factors factored in at one time. So you have the TV and the radio and the newspaper. You can spend 100,000 here, you can spend 50,000 here and 50,000 here, or you can spend 150,000 here, 25,000 here and 25,000 here, and they'll all give you so many different results if you would look at it. If it's $100,000, for example, here, you might get that many sales, this many sales, this, and also if you spend here $50,000 and you might get this many sales, these many sales, these many sales, and the same thing here. If you would spend $50,000, you might get this, that, and you might not even have an instance. You might not even have an instance. Let's say, for example, okay, um, if I spend uh, 95,000, 95,000, well, I don't have anything for 95,000 here, right? There's nothing for 95,000. So what would that be better? Would that be worse? I don't know. And let's say, for example, there's another instance here maybe that I don't have, whatever, just for example, let's just say, for example, there was nothing here, no information. Would that be a good thing that I would spend that much money versus spending 30,000 or 45,000? And how do these all three play, together? How do they connect together, all these three together here? That when I tweak TV, meaning if I, because obviously I have a limited amount of budget, so if I spend more on TV and less on radio and even less on newspaper is better, or should I spend more on newspaper and less on radio? So yeah, maybe here you can look at the graph and it's easier to see that TV, the slope is going higher, right? So that means obviously that the more you spend on TV, the higher the sales and radio, but not all data is so easy to visualize. And also, even if you can visualize it, there's some information that's not given. Like here, for example, in this example, when you spend 95,000, it's not there. So you can kind of guess it, you can come close, but you want to be as accurate as possible. And in some cases, it's just impossible for you to even to realize what would be the resulting prediction. Because here you have, for example, only TV, radio, and newspaper. But what about in different instances, like, for example, real estate, when you can have hundreds of different features that you can include in the model that would result in a certain prediction? For example, the number of bedrooms, the number of bathrooms, does it have a backyard or no? What location is it in? What is the demographics of the people living there? Is it near a big business or not? So many different features that can be included, and so many recorded real entries of previously sold houses with these different features. There's just so many that you cannot really be able to just graphically look at it and plot it down, or maybe you'll be trying somehow you'll be able to do it, but it will be just so cumbersome and with so many possible ways that you can be wrong in it that it would be really not the right way to go. So we want to make a machine learning model that would do this really quick for us in the most accurate way with statistical modeling, and like that we can really bring value to the company. So rather than guessing where we should budget the money, if we're going to distribute it between TV, radio, and newspaper, rather than guessing or trying to get, as close as possible, we're going to get real predictions based on statistical learning. I hope you enjoyed this, and we'll be learning much more later in the future videos.